Today, Academic Daddy is going to teach you everything on reaction of hydrocarbons. I believe you've heard of this. This is alkene. And alkene simply talks about single bond hydrocarbon. It simply talks about hydrocarbon that is saturated, hydrocarbon that has complete hydrogen. And I need you to know that alkenes undergo two major types of reaction. Number one is combustion reaction. What is combustion reaction? Combustion reaction is simply a reaction with oxygen. And I'm not talking about when you have an element reacting with oxygen. This type of reaction is called combination reaction. But when you have a compound, for example, this is what we call combustion reaction. And this type of reaction will always give you CO2 and water. So I need you to know that for every combustion reaction, alkene undergo two major types of reaction: combustion reaction and halogenation. So it undergoes cracking too, but I want you to know just this major two. Now, for every combustion reaction, once you see a compound with this, no matter how complex that compound is, know that what you will have is a combustion reaction. So let's do this way so that we can balance the equation, and you must balance it. So this combustion reaction means addition of oxygen. Halogenation reaction means addition of halogens. It means addition of halogens. Halogens are elements that fall under those group 7, like chlorine, fluorine, iodine, bromine. So those type of reaction, you know that they have the same reactivity because they are on the same group. So they always exist as diatomic molecules. So alkenes undergo these two major type of reaction: combustion reaction and halogenation reaction. Now, this is single bond. Alkenes and alkynes don't go through this type of reaction. So once you see straight chains combining with O2, just know that no matter how complex the end product is CO2 plus H2O. And if you know this, let's now ask ourselves, I have carbon here, 1. I have oxygen here, 3. 2 plus 1, 3. I have hydrogen here, 2 on the product part. Now on the reactant part, I have carbon here, 1. I have hydrogen here, 4. And I have oxygen here, 2. I have hydrogen here, 4. Now to balance this reaction, I see carbon 1, no problem. Always balance oxygen last. So I see hydrogen here, 2, here 4. Just take these 2 to this side and do 4 divided by 2 is 2. So So come and times it here, times 2. And you are allowed to put things on this coefficient. You know that's condensed. This is CH4. If you condense it, this is CH4. You're allowed to put something here, but you can never put something here on these subsets. Never put something here. Can never put something here. Can never put something here. It comes naturally. So this is something as CH4. So if I know that, I now have that this is 2. Now notice that the minute you put this 2 here, oxygen is now 2. So it's now 2. These 2 affects the whole compound 2. Then it has 2 here, which is 4. 4. So since I have 4 here, carry these 2, come here. Do 4 divided by 2. So it will give you 2. Carry that result and come here. Do it times 2. So this is now 2. So I write it 2. So that at the end of the day, I can clean this out. Why I'm bringing to divide is so that I know the coefficient I will put, since they ought to be equal. What you have on the reactant part must be the same with what you have on the product part. So if you know that energy can neither be lost nor created. So if you know that atom can neither be created nor destroyed. So if you know that the ratios must equal, it must have definite proportion. So this is its combustion reaction. Alkenes undergo this. Second type of reaction alkenes undergo is what we call halogenation. And if I have this is propane. This is propane. If you know that this is propane, when you add Cl2 or any of the halogens, this type of reaction is now what we call halogenation. And we know that chlorine, all those halogens, they don't exist as atomic, they exist as diatomic. So if you add this, it simply means that you need to know that this way that you have this is the same thing as Cl2 is the same thing as Cl. So if you know that, you need to also know that it simply means that this particular chlorine will come and displace this hydrogen, and this hydrogen that it displaces will come and meet this one. So if that is the case, I will now have that when this displaces this will leave the hydrogen. So notice it, I said that one of the chlorine or one of the halogens will come and displace this, so that it will now replace this. Then the hydrogen that it displaces will leave, then come and meet this. So that you need to know that anytime alkenes react with halogens, you will always have an alkane halide plus a hydrohalide. So if you know that now, let's try to write this out so that you now have that this is the same as having a C3H7 Cl. 1, 2, 3, 4, 5, 6, 7 Cl plus HCl. So alkene halide and the hydrohalide. Now, notice that it's simple. Once you know this, you don't need to be thinking about it too much. It's easy to memorize. So once I see that this is an alkane, the hydrogen is complete, because if it's 5 carbon, you have 5 hydrogens up, 5 hydrogens down. Then you have 1 to the left, right, and 1 to the left, which is 5, 5, 10, 11, 12. The hydrogen is complete. So once I see this, I immediately know that this is a halogenation reaction. All I need to do is remove one hydrogen here, then remove one of these, because this is sent as Br, Br, Br. Remove one of these and replace this so that I have C5H11Br plus the hydrogen that you removed, carry it and come here, plus HBr. So if you check it out, this is what you're supposed to have. So it's very important you know it. That is, it's an addition reaction. You are not losing anything, but it's just changing places. So once you know this, you know that every halogenation reaction of alkane must give you an alkane halide and a hydrohalide. I will impregnate you academically. Now let's move to alkene and alkynes. So alkene and the alkynes. So these two undergo 4 major types of reaction. Number 1 is what we call the hydrogenation. Number 2 is what we call halogenation. And as the name implies, hydrogenation means adding hydrogen. You know that hydrogen exists as a diatomic molecule. So adding of hydrogen is called hydrogenation. Halogenation means adding of halogens, be it chlorine, be it bromine, or the rest. You know that they exist as diatomic molecules. So adding of halogens is what we mean by this. Then number 3 is hydrohalation. And adding of hydrohydrogenation, just as name implies, means hydrogen and halogens. So adding of this. Then number 4, it can be chlorine, it can be bromine, it can be fluorine, it can be iodine. So, but whenever you're adding halogens and hydrogens, it's called hydrohalogens. Then the 4th one is called hydration. And in hydration, it means adding of water. I don't want you to think of it as water, think of it as adding of hydrogen ion, which is hydrogen and OH. let's go over this and see if it's balanced. This is 1, 2, 3, 4. That means this carbon is balanced. 1, 2, 3, 4. This carbon is balanced. 1, 2, 3, 4. This carbon is balanced. 1, 2, 3, 4. This one is balanced. So looking at this, we see that this is having the longest carbon chain to be 3. So this is propane. So either you're going this way 1, 2, 3, or you're going this way 1, 2, 3. So this is propane. Now let's see. We now know that this can only undergo 4 major reactions. So let's add hydrogen to this. Hydrogen, think of it this way. So naturally, when alkanes, for it to be an alkane, it lost 2 hydrogens. Notice this. If I have this, this is an ethane. All the hydrogens complete. For it to be an ethane, it will lose this, then take up a double bond. So if this is what ene looks like, it loses 2 hydrogen. Now you adding the 2 hydrogen is the same thing as saying taking it back to ene. So when you add this now, you are taking it back so that it will lose the bond. So anytime you are doing hydrogenation reaction, you are adding back the hydrogen, and if you add back the hydrogen, you are breaking the bond. So know it that every alkane and alkyne reaction is always attacking the bond. Your focus is on the bond. Your focus is on the bond. That bond will have to be broken. The bond will have to be broken. And when you break this bond, if it's an alkyne, it will change to alkane. If it's an alkane, it will change to an alkane. So knowing that, when I know, let's carry this now to where it's happening. So that I'll bring this here, So let's react this. So we are carrying it to where it's happening. It's always on the bond. So that means this bond will come to this, and when it comes, one of the hydrogen is coming. So if it comes here, it is now broken. So that if it comes here, it will come and be for this one. Now this particular bond here will be broken, and it will go here. So that this will now carry this, and it will be broken. So when you check it, you see that you've been able to take this from an alkane to an alkene. So this is now propane and no longer propane. And let's say this is plus. And let's say this is plus Cl2. Let's say this is plus Cl2. I want you to see the Cl2 as ClCl. And I need you to know that you don't have to think of it far. Carry the ClCl to where it's happening. Your goal is always on where you have the double and triple bond. So this is what it means. You can make a rough sketch. Once you're given this kind of question, carry your own and go there. This bond here, carry it for one of this chlorine so that it will now come here. And when you do that, it disappears. Now this bond here, break it so that it's come here. And when you do that, it's now standing. So this.